In this lesson, you'll learn to use algebra to write two-column proofs and use properties of equality in geometry proofs. How is mathematical evidence similar to evidence in law? Lawyers develop their cases using logical arguments based on evidence to lead a jury to a conclusion favorable to their case. At the end of a trial, a lawyer will make closing remarks summarizing the evidence and testimony they feel proves their case. These closing arguments are similar to a proof in mathematics. And here, once again, for your listening pleasure, are the properties of equality for real numbers. You've been working on them for years. The reflexive property. For every number a equals a. The symmetric number property. For all numbers a and b, if a equals b, then b equals a. The transitive property. For all numbers a, b, and c, if a equals b and b equals c, then a equals c. Addition and subtraction properties. For all numbers a, b, and c, if a equals b, then a plus c equals b plus c, and a minus c equals b minus c. The multiplication and division properties. For all numbers a, b, and c, if a equals b, then a times c equals b times c, and if c does not equal 0, then a divided by c equals b divided by c. Substitution property. For all numbers a and b, if a equals b, then a may be replaced by b in any equation or expression. Distributive property. For all numbers a, b, and c, a times b plus c equals a plus b times a plus c. The properties of equality can be used to justify each step when solving an equation. A group of algebraic steps used to solve a problem form a deductive argument. To solve this equation, the first thing we'd want to do is distribute. So we'd have 10 minus 6a minus 4a minus 28 equals 92. And we need to write our properties out, so that was distributive property. I'm going to abbreviate. Next thing I'd like to do is combine my like terms. So 10 minus 28 is negative 18, and negative 6a minus 4a is negative 10a. And they call that substitution because all I did was add. Then I can add 18 to both sides of the equation. So we've got negative 10a equals 110, and that was addition property of equality. And divide both sides by negative 10. A equals negative 11, and that was division property of equality. Now, if you look at the book, they may have more steps than I do because I can combine things, and that's okay as long as you have a reason for each step you do. In geometry, a similar format is used to prove conjectures and theorems. A two-column proof, or formal proof, contains statements and reasons organized in two columns. In a two-column proof, each step is called a statement, and the properties that justify each step are called reasons. For the proofs we'll do from this book, every one will start with what we are given. So they want us to write a two-column proof if 7d plus 3 divided by 4 equals 6. And then we want to get to prove that d equals 3. So we are always going to start with what we are given, and we're going to use deductive reasoning to get to the thing we're trying to prove. So the first thing I'd want to do is multiply both sides by 4. So I'd have, if we multiply by 4, 7d plus 3 equals 24. Okay, that was the multiplication property of equality. And next, we'd want to subtract 3 from both sides. So I have 7d equals 21. So that was subtraction property of equality. Now, if you look in the book, they have about twice as many steps as I do because they have a substitution between each one of those. I find that unnecessary. I just Divide both sides by 7, I have D equals 3, and that was division property of equality. Now, if you look at the book for the exact same problem, they have 7 steps, I have 4. As long as you can show your reasoning from one step to the next and the reasons, that's okay. This is geometry, so where we're really heading, it's not algebraic proof, but geometric proof. Since geometry also uses variables, numbers, and operations, many of the properties of equality used in algebra are also true in geometry. For example, segment measures and angle measures are real numbers, so the properties from algebra can be used to discuss their relationships. Some examples of these applications are shown in the chart. So reflexive, a segment length is equal to itself, or angle measures to it's equal to itself. Symmetric, if A equals B, AB equals CD, then CD equals AB. And transitive works as well. If GH plus JK equals ST and segment ST is congruent to segment RP, then which of the following is a valid conclusion? GH plus JK equals RP. Sure. That's just a nice substitution because the length of RP is equal to the length of ST. PR equals TS. Yes, congruent segments have the same measure, so that one works. GH plus JK equals ST plus, no, you can't just add RP to one side, so no. So our choice is going to be B. 1 and 2 work, 3 does not. A starfish has 5 legs. If the length of leg 1 is 22 centimeters and the length of leg 1 is congruent to leg 2 and leg 2 is congruent to leg 3, prove that leg 3 has a length of 22 centimeters. I'm going to scooch this up a little bit. Okay, they gave us a lot in the given here. Leg 1 is congruent to leg 2 is congruent to leg 3. I'm going to stop there for now. And the reason I can put that in my statement is because it was given to us. So that looks like a classic statement of transitive property. We can say leg 1 is congruent to leg 3. That's our if A equals B, B equals C, then A equals C. So transitive. So if the leg measures are congruent, they must have the same length. And that is just the definition of congruence. And I'm going to abbreviate def congruence. The last statement from our given was that the measure of leg 1 equaled 22 centimeters. So that was given. And then, again, using the transitive property, we can say that the measure of leg 3 must also be 22 centimeters because we just said they had the same measure. So we're just connecting what we were given using the properties we know. The properties of equality used in algebra can be applied to the measure of segments and angles to verify and prove statements.